Hello, new video. This time I thought I would go over probabilities. So, I was thinking how to prove that what we were seeing in this is more than just random chance. And I'm not a statistician, or I'm not good at I should say I have done, a decent number of probability and maybe one or two or three statistics courses in my life, but I have a degree in mathematics, and mathematics is definitely not probability or statistics. Statisticians use mathematics just like economists and physicists and everyone else does, but mathematics is a whole different beast. And dare I say, at risk of offending my audience, math is a lot tougher, but it is has a different application. And in this particular situation of trying to prove the model, statistics is usually the tool for the job, despite the fact that stats itself has got a reputation over the years of being a great tool for lying about whatever you're trying to present. And I've got some favorite articles about that. The guy who, statistically proved that chocolate makes you thin, even though it didn't. And after he tricked the media into airing his story around the world, he went and released how he fooled them all just by, hacking p-values or whatever. So I don't like stats, but nonetheless, here is stats to try to prove my method. And what kind of statistics? I thought I would go with the birthday problem. I realized, so the birthday problem is how big of a group of people do you need before any two people in the group share a birthday, right? And coincidentally, birthdays are on 1 out of 365 days in the year. And the days of the year, 365, that came from the old, Coptic calendar, which probably came from the Babylonian calendar, 1 in 360, which is where we get our 360 degrees from. And coincidentally, I am searching for geodesics on, 1 of 360 degrees. Or in this case, my circle tightness is put on 0.1 degrees. But equivalently, if I set this threshold to searching for geodesics of 1 degree, what this is essentially doing, and let me change here to my favorite flat earth mode, right? And let's use my new center on quake feature and turn up the geodesics. Touching none at the moment. So, actually for visuals, let's just touch a few geodesics. So here's our geodesics, right? And it's searching within 0.1 degrees, so this is the same as chopping this. Actually, once again for visuals, let's just search 1 per degree. So this is looking for, the way this algorithm works is, from this perspective, it looks for all, it slices the flat Earth, azimuthal projection up. It doesn't exactly use this projection with this method, but it projects to planes and then searches for angle tolerances. It does the equivalent thing of what we're seeing here. It basically, with 1 degree here, is the same as chopping this up into 360 slices and looking to see if there's 2 things in the same slice, right? It's the birthday problem. It's the same thing. So that means that if the birthday problem, if you work the math out, your group only needs to be, I just looked at it. I think it's 23 people, something like that, before statistically you have got a 50-50 chance of any 2 having overlapping birthdays. And so that means that if we are looking at 23 points, or whatever the number is, points, then, once we get past that number, our odds are going to be 50-50 or more that any 2 are overlapping. And finding geodesics in that case will basically be noise, right? So I'm going to try here to convince you guys that we're not getting noise and that it's above whatever threshold we're looking for. And let's go back to, I think it was at point 1, right? So this is the same as if your birthday calendar has 3600 days on it, but you're still looking for the birthday problem. And if you work the math out for this one, and I just didn't, so I just remember this, it's something like 70.9. So once you have more than 70.9 people in a group, if your calendar had 3600 days on it, then it's 50-50 that two are going to overlap, right? So how many quakes do we have here? 104, so that's well over the 50-50 mark. We should have one touching. Odds are some, or geodesics will touch the center quake. And sure enough, we have some touching. Let me tone this down also. So let's go back to, this is the time that we're searching for quakes. So this is just going to shrink our number. So now we only have 28. Now we're well below the 50-50 mark. And in fact, yeah, sure enough, we're not touching any, just like we would probabilistically expect. So what I've done here is I pre-cached these values for the odds of having an overlap for a certain group size, depending on some familiar partitions like our 3600 partitions here, right? And for this particular angle threshold, I just said it's like 70.9 we need. So I'm just going to now cycle through a few earthquakes, and we're going to see if they overlap or not. And this is going to show us here in the corner, it's going to show us what the odds are for the current number of quakes that an overlap happens out of 3,600 partitions. And then it's going to show us our running total. You know, right now it's 0 is our running total, right? We had 0 out of 1 pairs with our current data set of 28 possible quakes that are on display at the moment. I think it should be 27 actually. I think I'm including the one that we're centered on, which means that this will it means that the odds should be even, like if I pass this test, it proves it even more. So by one, one out of this, by one less either way. Here we go. So here we had found 0. The odds of finding 1 would have been 0.9, right? And once again, the odds of finding this, this is like what? This is going to be 0.09. This is like 9% and 8% chance of success, and we failed twice, so it's expected, right? But if we keep on going, eventually we're going to find we're going to build up our probability. Here we found 3 out of 19, so our success is at 15.7%. All of a sudden, we're above par, right? I'm not a statistician. I'm not a I don't know if that's the word, probability mathematician, whatever. I'm just the regular differential geometry, general relativity, the kind that does the tough stuff, I guess, the fun stuff. The stuff that all my PhD dropout friends or coworkers that I've ever met all dropped out of their physics PhD because they couldn't do. That's the stuff that I do. Ironically, no PhD wants me. But that's a whole other story that I kind of half alluded to of several videos in the past. Maybe I'll tell it one of these days. But either way, let's keep adding to our results, and we're going to settle at something. We kind of already have. We're right about what we're settled at. So our total or running total is right around 10%. From 0.08 to 0.09. Up to here we have 0.11, 0.12 because we're getting a bit higher number of quakes because our window is only in the past, so it's not going to grow as we go back in time. Never mind that. It's just a more dense period of quakes at the moment. So, but either way, we're also getting more winds. It's going to settle. If I happened to pick these numbers like I did for the last run, it's going to settle at. It's going to have some 0.03 on the left side, and then it's going to be 0.06 or so on the right side. But yeah, technically to correctly calculate the odds that it should be, because I'm only showing you the odds it should be for any one specific instance. So technically you should, I forget exactly, it's like the same formulation as the birthday problem where you do like 1 minus 1 minus this quantity, I don't know, or maybe you do a Bayes theorem, maybe you do something else. I'm not a probability guy. Nonetheless, this is just showing you the running true versus false here. And the running true versus false, we're right at about 50% whenever we have never yet seen for a specific set of earthquakes, it should ever be at 50%. And so to me, that means that whatever phenomenon we're looking at, that we're seeing these geodesics pop up, it's well above par, right? And even if I subtracted that one, it would just make the odds harder to beat, and they're still beating the odds. And here's the final result I was saying. I was seeing that like 0.03 on this side, and then we are getting 0.06. Sorry, I said that wrong. 0.30 on this side, and we're getting 0.60. So we're seeing about 60%, and now it's going to start to settle, or converge, I should say. We're seeing about 60% of the time that of all the quakes we're looking at, our geodesic is passing through 2 of them, i.e. 2 of our quakes when projected to these different 1/10 of a degree slices. 2 of our quakes are on the same slice. Birthday problem with 3,600 days in the year. And it's happening more often than it should for our number of quakes, which, at first it was just a few, 30, 25, 30, 20, 25, 30. Now it's up around 50, 40, 50 or so. But the odds that we're getting are more than the odds that it should be. So I don't know how to interpret that, but other than the fact that this means that we're defying the odds, that there are geodesics more often than there should be if the points themselves were random. So I just wanted, here we go. It has dipped down once again from 60 down to 30, so our chances of it happening, and this is the odds of birthday problem, the odds of a pair happening at least once. I looked a little into the math for the odds of a specific number of pairs happening, because we're finding here 2, 3, 4, how much, 19 in one case. So if I did that math, which I haven't found the formulas yet, and I'm not going to look, if I did this math, I think that it would be a lot more tight than just 36.9%. 36.9% is the odds of finding one pair. We found 19 pairs. The odds of finding 19 pairs out of 58 is probably a lot smaller, and we're still beating it because we're getting 60% true, right? So, 60% of the time we are seeing a geodesic through our tighter constraints, right? All the times before I was saying, wow, every single time within 3 days, there is a quake there's 3 quakes within 0.1 degrees. Now I'm just looking at 1 day, which is why there's not as many geodesics showing up, but we're still seeing it 60% of the time, converging on. And still kind of going up a bit, but still kind of, before it was kind of oscillating up and down around there. But I guess as this left-hand number is getting smaller, this one's probably going to start going up even more. But either way, there's me trying to prove that what I have found defies statistics. If I have concluded anything incorrectly, feel free to explain it to me. If if you see anything wrong, tell me. If you don't, then honestly, after the last video, you don't really need statistics. I was going over all the geodesics, and they were all lining up with the 6.3 Columbia quake. And when they weren't, they were lining up with the 6.4 quake from the day before, what was that, Argentina? It's pretty obvious something's going on here, right? But either way, here's me just trying to use some stats to prove it. So, thanks for watching.